This presentation is on experimental and quasi-experimental designs for criminal justice research. These are the type of designs that we use where we are comparing different samples. So let's begin. First, this type of design is an approach to research that's best suited to explain and evaluate the data sets that you have, the data that you have collected. When you're comparing groups, this is the type of design that you would like to use. An experiment is defined as a process of observation to be carried out in a situation expressly brought about for that purpose. They involve taking action, observing the consequences of that action, and these are especially suited for hypothesis testing. So when you have a hypothesis that we want to test through statistics, we use the experimental method. There are three central features to the classical type of experiment. Now, at this point, we're talking about experimental designs, not quasi-experimental. Those are a different kind that we'll get to in just a few minutes. But these central features include an independent dependent variables, could include pre-testing and post-testing. So this is when we might be doing recidivism rates for juveniles incarcerated, and we might look at the recidivism rates prior. Well, let's do it. Let's do a different one. Let's say that we want to see how a program um, uh, um, success rate while incarcerated. So we might do a pre-test of recidivism rates for inmates that did not receive the treatment. And then we might have the post-testing, which would be the recidivism rates following participation in a program. Also, the classic experiment includes experimental and control groups. We have at least two groups of subjects that you are evaluating. So in the field of criminal justice, we might be using, which we are, many of you are comparing different groups. For instance, comparing juveniles that are incarcerated to juveniles that are not incarcerated and comparing their recidivism rates. That it depends on what the focus of our study is. If I'm saying that recidivism rates increases during incarceration, that's going to be my experimental group. That's the group I'm really measuring. But I'm going to compare that to a control group of those that are not incarcerated and offenders that committed the same crimes, a lot of the same demographics. And so I would compare those two groups in regards to recidivism. The independent variable that we're talking about in experimental designs takes on the form of a dictamonious stimulus that is either present or absent. It might vary within our experimental process. This is the cause. We want to see what the cause is on our independent variable. The independent variable in the example I just gave you would be recidivism. Sorry, backwards. The independent variable would be the offender, whether the offender is incarcerated or the offender is non-incarceration. And the cause on this would be our dependent variables, the outcome or the effect we expect to see, which would be recidivism in the example that I gave you. This relies on the independent variable. In other words, it's going to, whatever the result is, comes from what the independent variable. And in this case, the independent variable is being incarcerated or not incarcerated. So depending on where they're placed will affect our dependent variable. Now, this is an example of pre-testing and post-testing. This is not always used in experimental research. As I gave the the example, it might be to test a certain type of program for incarcerated youth. Maybe we're going to check one experiment that has been done prior was with violent juveniles in prison. Wanted to see how incorporating a program would increase or decrease their violent behavior while in prison. So they basically took a sample of violent offenders, randomly selected them into two groups, which gave our experimental group and our control group. The experimental group uh, was going to receive the program where the control group was not. So both of them were tested in regards to their level of violence prior to this division. Then those groups were exposed to the independent variable, which is the program that we're offering to these juveniles. Then, after the program is completed, they are remeasured. They're post-tested. They're measured again in terms of their violent behavior to see if there's any difference in the two. Again, this is just telling you what I said, that the experimental group, that is the one that is exposed to whatever treatment or policy that we are testing. And in the example I gave you, it would be the treatment program. The control group, we try to have these two groups as similar as possible in order with, like if we were doing the offenders, we would want those offenders to be as similar as possible. Um, like between a certain age, maybe committed a similar crime, maybe have the same level of violence involved in the facility. And so the group that does not receive the treatment is considered the experimental group. And remember when we talked about validity, we hope in order to have validity for our experiment, we want the difference to be as a cause of the independent variable and not due to a difference between the two groups. So obviously, if we were to use a group of offenders that committed misdemeanors as opposed to offenders that committed violent crime, they wouldn't be similar. So any of our results would not be worthwhile. Now, in the example I gave you, um, it wouldn't really be a placebo, would probably not be evident, but a placebo is because we don't want people to know if they are receiving treatment or not. So we don't want to know a difference between the two. And this happens a lot. Think about it with uh, medical, where the placebo is given and one gets the true treatment and one does not. And you can also do this within regards to a certain kind of program. What you would do in the case of what we're talking about, we would divide our experimental and our control group, and our control group would go into a room or pretend to go to a program, and maybe they wouldn't do much of anything. Maybe it would just be letting them sit and draw. Bad example, but and then the experimental group would actually be getting the treatment and the program. When we do the placebo, it does ensure that its changes in the dependent variable, in our case, the recidivism, actually did result from the independent variable. But again, it doesn't always occur. This doesn't really reflect the kind of research we're talking about. Now, when we talk about the double-blind experiment, in the double-blind, it's really like it shows that the researchers, the experimenters, the ones that are observing the experiment or participating in the experiment, don't know which subject received the treatment. Um, and this could be in the case of, let's say that we are looking at violent offenders and we want to see how a particular type of food impacts their behavior. So maybe the experimental group receives just a healthy meal where the control group receives a more sugary um, meal. So in order to do this, you wouldn't tell anybody either way what group it was, and then those that are watching are just watching for certain behaviors. Broward County, Florida, and Portland, Oregon did a domestic violence policing units where they studied the keeping safe strategies, and they did this, where they had their double blinds, and neither one that was participated knew who had what. Selecting subjects. This is done, we've talked about this, about how to get our sample. First, we have to decide on the target population, right? In the case I gave you, we're talking about violent juvenile offenders incarcerated. That's the target population. So this is the group which the results of the experiment will apply. Second, we need to decide how to select the members from that group for the experiment. Now, the difference in experimental and quasi-experimental is very evident right here. The experimental group is randomly selected. So if we have a population of 1,000 juveniles incarcerated, and they're all violent. Let's say they're all serving a sentence on a violent offense. Of that 1,000, we would select the members randomly. And as I said, we'll go over this type of sample later on, but randomly, let's just say we pick every 10th offender on a list of offenders, or we have, what's nice now, computers can do this random selection for us better than us. And this again ensures that the experimental and the control groups are as similar as possible. So when you would randomly select those juveniles from that 1,000, you wouldn't decide which is going into which group. It would just be randomly selected at that point too. Randomization is very important when we're looking at the experimental groups. It is the central feature of the classical experiment. It produces the two groups that are as statistically equivalent as we can make them. The classical experiment, when it is completed as it should be, it would reduce the threats to the validity of the causal inference. In other words, the cause would precede effect via taking the post-test. You always want the cause to precede the effect. That makes most sense. It ensures an empirical correlation exists comparing the pre-test to the post-test. It also ensures that there's no spurious third variable influencing the correlation. So there's nothing else, as in a demographic, or if the control group and the experimental group are very different, then there could be something else that's causing the result besides what our treatment, our causes, our experiment. If we do have some of those threats that I just mentioned, the conclusions and the results that we find from the experiment may not reflect what really went on in the experiment. So that's why we want to control for those other variables. The history of external events have been shown to occur during the course of the experiment. For instance, within our example that I gave you of the violent juveniles in our control and experiment, what if during the course of the testing, the experimental group all received a notice that they were going to be released early? That's an external event that couldn't be controlled for, that could impact the results. As also maturation, people are constantly growing. So when you do a experiment over a long period of time, you have to control for that, and you have to test for that, as well as the testing process. Just the whole process of testing and retesting needs to be as similar as possible. Remember when we talked about our validity, and that if we were to give two different tests, one at the beginning, one at the end, that means nothing. It's meaningless. So the test that we give, in our case, is the level of behavior. But say that that's being measured by a measurement tool that is used, one of these testings, and say we use a different test, or even say, let's say that a psychiatrist or a psychologist, social worker, are measuring the level of behavior, violent behavior, by the number of attacks. And let's say that in the post testing, they don't do it in the same way, or it's measured by the number of times they're violent, not necessarily the times that they were caught, but maybe the times that they report. So anyway, there's a difference between, you want to make sure that the same testing is done post and pre-test. Some of the other threats are instrumentation. There may be changes in how, like I just said, how the process of measuring the violent behavior. Also, you might have extreme scores that regress to the mean. This may not happen in the example I gave you, but it could happen in measuring recidivism. Maybe some of the scores of the offenders, some of the recidivism was so very high that it kind of throws off your mean. It throws off your distribution. Selection bias, the way in which they are chosen. If they're not chosen in a random assignment, that can be a threat to internal validity. And mortality. Sometimes subjects may drop out prior to the completion of the result. I mean, maybe they're paroled, maybe something happens and they're transferred out, maybe they just decide they don't want to participate anymore. Some more threats would be the causal time order. Causal time order is the ambiguity about the order of the stimulus and the dependent variable, and it's hard to, and within the example I gave you, but if you have your stimulus and your result that are mixed up, or you're not sure which caused which, it may be the change in the behavior was just caused by them individually. Maybe it had nothing to do with the result. Also, there's the threat that these two types of groups could communicate. They could talk. What if part of the experimental group were just to be talking to the other inmates and telling them what they were learning in the experimental group, and this were to rub off on them, like, hey, yeah, that's pretty good. I might have to try that. And therefore, you have your diffusion, your imitation. Compensatory treatment. I'm not sure this really relates here to my example, but let's say the control group is deprived of something else that would be considered of value. What if they, within my example, they were deprived of outside activity because that's when we had to pull the control group aside? That would be a threat to internal validity. And both of these threats are very similar. If the control group is deprived of a stimulus, doesn't receive something, it may cause them to work even harder. And so then it's not just the idea that they're not getting the treatment. And they might feel deprived if they know that the experimental group is getting this treatment. They could just give up and say, well, what does it matter how I do? I'm not getting that treatment. It's not going to help me get out any earlier. As with any research design, the external threats are just as important as the internal threats to validity. And when we look at this between cause and effect with our experiments and our true experimental design, there are two dimensions of generalizability that we want to look at, and that's construct validity and the external validity. Remember that the external validity is being able to generalize your results across the entire population. So if you're unable to do that, then you have a threat to your external validity. Now, construct validity in the language of experimentation is really concerned with generalizing from our observations in an experiment to the actual causal processes in the real world. So the fact that can we relate what we saw within our experiment uh, controlled from our experimental to our control group to the real world? And as I just stated, depending on how well the experiment is controlled, would reduce the threats to external validity. Now, remember when we talked about statistical conclusion validity, and I said I would kind of get into this more later? Well, we will when we talk about more statistics, when we get to talking about bivariate statistics. And one thing I want to mention, and I should have in my other PowerPoints, um, well, this is not the place, um, but the statistical conclusion validity is that we are always looking for a statistical relationship between our variables. So when we test the results of the control group with the experimental group, we get what's called statistical independence and statistical significance, and that is told to us by a result from whatever type of statistical test we get. So when we are reading our results, it'll tell us a certain number that we'll know that it did not uh, if it's within a certain range of numbers, and I know I'm being very vague here because we'll talk about this more when you understand about statistical significance, but if uh, the result turns out to be statistically significant, that means that they do impact. That means that the independent variable does in fact impact the results. So when we look at the threats to this, there's a number that we need to just go over. It is an issue when they are based on small samples. Remember, the larger sample we have, 100, is great. The less threat to this statistical validity, because the more cases that you have, they allow you to detect smaller differences, and the less cases result in a detection of larger differences. We want to find the cause and effect relationship. And when you're using the experimental design, it depends on two related factors, and that's how many subjects you have, we just talked about, and the magnitude of post-test differences between the two groups. So if there's a huge difference and it's significant by testing our statistics, then that gives us a result. There are a number of ways in which a classical experimental design can be conducted, and there's four basic blocks present in the experimental designs that can change the result. If the experimental and the control groups, sometimes there's more than just the two. There could be a number of different groups that would impact your results. Also, the number of and the variation of your experimental stimuli. In other words, if the stimuli that's being given to the experimental group varies greatly between groups, especially if you have more than one experimental group, this is going to impact your results. Also, too, the number of pre-test and post-test measurements. Sometimes you might pre-test a couple different ways and different times, which will change the variation in the design. And also how the groups are selected. How are the subjects, the cases selected for each group, and how are they assigned? That can also vary in the experimental design. Now we're going to talk about quasi-experimental designs. Quasi-experimental designs, it's also using the experimental method where you're going to have your control and your experimental group, but under these designs, randomization isn't possible. So let's say that first of all, you may not, maybe in a quasi-experimental, maybe you want to test recidivism rates for offenders released from incarceration. And you want to test recidivism rates for those that went into a program and those that did not. Well, in that case, you have to put them into those groups. So already you're not randomly putting them in either group. You have a group that has to be this way or has to be that way. This does subject to internal validity, but again, anytime you have these threats, you want to do everything you can to control for them. And when you're writing up your research, you include all of these threats. And even though, let's say we're looking at male and females, well, we have to put them in a certain group, right? We have to put the males together and the females together. But we also want to try, after we have done this, to make these groups as similar as possible. So we might want to pick females that have committed a violent offense between the ages of 15 and 17, and we'll do the same thing with the males. So we take these steps to make them as comparable as we can. One of the designs that we have under quasi-experimental is the cohort. And we talked a little bit about this when we were talking about time series and the birth cohort, where the researchers picked a cohort that was born in a certain year, and they followed them throughout their life of 18 years. So that's your cohort. They are quasi-experimental because they are placed. You're choosing a certain type of subject. And even if you're examining two cohorts, you again want to make sure that those that are examined against each other are as comparable as you can. And in the quasi-experimental, we also might have time series designs, which are the longitudinal studies where we examined the process over a long period of time. So, for instance, are we measuring recidivism following incarceration? We might measure it over a period of 2 years following incarceration. And we might measure it at certain times. We might measure it at 3 months, 6 months, 12 months, and 24 months. And then we compare, which would, the cause and effect, we compare the first 3 months to the last 3 months. You might want to use variable-oriented research and scientific realism within your quasi-experimental. So you might have a large number of variables that you want to study in a small number of cases. You may only have access to a small number of cases, so you're going to try to study as many variables as you can. You also might have many cases, and you might want, if that's the case, you might want to understand just a small number of variables. That was done in the Boston Gun Project. That's case-oriented research. You might have a large number of available variables that are studied for a small number of cases. That could be variable-oriented research. And the case study design is centered more on an in-depth examination of one or a few cases on many dimensions. So you might use the quasi-experimental, and you might even be using qualitative research. So you might, really sit down and follow a police officer, a female police officer. And I keep going back to the female police officer because there was a very good qualitative research completed where the researcher really case studied just one or two in depth. Okay, that's all we've got on experimental and quasi-experimental. I'll be going over any more of this in class on Monday, but I really want to try to concentrate more on the descriptive statistics so we can do examples in class and really discuss that also as it relates to your own research.